Hi. In today's video, we're going to talk about end behaviors of polynomials and how we can use end behaviors along with some of the other characteristics that we know to graph polynomial functions. So we first need to understand what an end behavior is and how we can determine what it is based on the polynomial function. So an end behavior tells what happens to the f of x, or to the function, also known as the y value, as x approaches infinity, positive infinity, and as x approaches negative infinity. So when x is approaching positive infinity, we're saying that it is getting bigger. So as x gets bigger, we want to know what happens to the y values. And as it's approaching negative infinity, that means x is getting smaller. So as x gets smaller, what happens to the y values, or the function that we're looking at? So we determine end behavior by looking at two parts of the function. The first one is going to be the degree. So the end behavior is first determined by the degree of the function, and then we look at also the leading coefficient. So the degree is going to tell us whether the function is odd or even. So if it's an odd degree function, then it's going to be an odd polynomial. If the degree is an even number, then we're going to have an even polynomial. The leading coefficient of the polynomial will tell us positive or negative. So obviously, if the leading coefficient is positive, we have a positive function, and if the leading coefficient is negative, we have a negative function. So those are the two parts of the polynomial we're going to look at to determine the end behavior. And basically, all polynomials are going to fall into one of four groups or categories. We're going to have positive odd functions. We're going to have negative odd functions. I'm sure you can figure out the next two. We'll have positive even functions and negative even functions. So again, like I just stated, the positive and negative part, so whether the polynomial is positive or negative, comes from the leading coefficient, and whether the polynomial is odd or even is going to come from the degree of the polynomial. So let's take a look at each of these four different categories. There's actually a document on my website that you can download, and it'll have all four of these graphs basically in one place if you need it to print it out and have it available for you. But the first one we're going to look at are positive odd functions. So the simplest positive odd function that we know is f of x equals x. This is really x to the first, so 1 is an odd number, so it makes it an odd function, and the leading coefficient is 1, positive 1, so it makes it a positive odd function. And if we think about the graph of f of x equals 1, or I'm sorry, f of x equals x, we know it is just a straight line. So when you're encountering a positive odd function, if you think about just the straight line and the characteristics of this line that we're about to go into, that'll apply to all positive odd functions. So back in the beginning I said we want to look at what happens as x approaches positive infinity, meaning as x gets bigger. So on this side to the right is positive infinity, to the left is negative infinity. The y going up is positive infinity, and y going down is negative infinity. So the way we describe the end behavior, as x is moving towards positive infinity, so as we are going to the right, we want to determine what happens to our y values. And since the arrow, an easy way to think of this is the arrow is pointing up, and so our function, f of x, is also approaching positive infinity. So then we look at as x approaches negative infinity. So what's happening to our function as x gets smaller? So as we go to the left, what is happening to the f of x function? You can see that it is going down, and so we can say f of x approaches negative infinity. So like I said, all positive odd functions will follow these characteristics where as x approaches positive infinity, f of x approaches positive infinity, and as x approaches negative infinity, f of x approaches negative infinity as well. What you're going to notice is that for odd functions, the end behavior, so what your f of x is doing, they're going to be opposite. So we have a positive infinity for one and a negative infinity for the other. So for odd functions, you want your end behaviors to be negative, and we can see that from the graph. In one direction, we're going in one way, and in the other direction, it's going towards negative infinity. Okay, so now the opposite of that, we have negative odd functions. A negative odd function is we're still going to look at f of x equals, instead of x, we're still looking at a line, but it's going to be negative x. So this function is going to look like this, where we still have positive infinity and negative infinity over here, positive infinity, negative infinity there, but because our leading coefficient is now -1, that's what makes it the negative odd function. So what is happening to our function? As x approaches positive infinity, now we can see that f of x, it's actually going down. So f of x, we're going to say, approaches negative infinity. And as x approaches negative infinity, f of x, so as x gets smaller, we can see that the function, the f of x function, is getting bigger, so f of x approaches positive infinity. And again, because it's an odd function, our end behaviors for our f of x, they're going to be opposite. Okay, so those are both your odd functions, positive and negative. Now we're going to take a look at positive even functions. And the simplest positive even function we know is f of x equals x squared. 2 is an even number, so it makes it an even function, and our leading coefficient is positive, so we have a positive even function. And if you recall, that graph is a parabola. So all even functions will follow the same end behavior as our parabola here. So as x approaches positive infinity, we can see that our f of x is pointing up, so f of x is also approaching positive infinity. On the left side, as x approaches negative infinity, what we notice is f of x is also approaching positive infinity on this side. It is increasing. The y values are increasing as well. So for even functions, we want our end behavior on both sides to be the same. So in this case, they're both getting larger. The y values on both sides are getting larger, so they're both approaching positive infinity. If we look at the negative even function, so I'm sure by now you can figure out we're going to look at f of x is going to equal negative x squared, which our graph for this is an upside down parabola. Looking at this function, as x approaches positive infinity, what happens to the y values? What happens to our f of x? Well, in this side, on the positive infinity side, our function is pointing down. So we're going to say it approaches negative infinity. And then as x approaches negative infinity, what happens to our function? On the left side as well, our function is going down. The y values are getting smaller, so we are also approaching negative infinity. And like we said, for even functions, we want the end behaviors to be the same. In this case, they're both approaching negative infinity. So I know it's a lot of information. Like I said, there is a document on the website that you can print out that has all 4 of these graphs along with the end behaviors for each one, so that if you need to reference them, you have them readily accessible. I encourage you to do that. But let's take a look at an example. So we have p of x equals 2x to the 5th plus 3x squared minus 4x plus 1, and we want to determine the end behavior. Now, as you recall, the end behavior depends on our leading coefficient and our degree. So let's figure out what both of those are first. Our leading coefficient here is going to be 2. So, and because it's a positive 2, that's going to give us a positive function. our degree is 5. The highest degree of this polynomial is 5, which is an odd number. So we are going to end up looking at a positive odd function. So I encourage you, once you figure out what type of function you're looking at, to just do a quick sketch of the graph that represents that type of function. So positive odd function is a straight line going up towards the right. And from there, we should be able to identify our end behavior. So as x is approaching positive infinity, so as x is getting bigger, what is happening to our y values? Our f of x is also approaching positive infinity. And then as x approaches negative infinity, so as x gets smaller, our f of x is going to approach negative infinity. So you don't necessarily have to memorize the end behaviors for each of these 4 different graphs, but if you can sketch the graph that represents the positive odd function, you can use that graph to come up with your final end behavior. So let's take a look at one more example. P of x equals negative 3x squared plus 4x plus 1. So we're going to start by identifying the leading coefficient. Our leading coefficient is negative 3, so negative, so it makes it a negative function. And our degree comes from the largest power here, so 2, which is an even number, so we're looking at a negative even function. So our even function was a parabola, and because it's negative, it's going to be upside down. So once I have the sketch that represents a negative even function, I can find the end behavior that is going to describe my p of x function. So as x approaches positive infinity, f of x approaches, so what is happening as x gets bigger, what's happening to my y values? They're getting smaller, so negative infinity. And then as x approaches positive infinity, my f of x is approaching, and again, as x gets smaller, so as I move to the left, my y values are also getting smaller, so these also approach negative infinity. And we had that little check. We said, remember, if you're talking about even functions, you want the end behaviors to be the same for both. So that's a good little check. If you remember that, you can make sure that what you've written reflects that as well. So it's a quick review of end behaviors, how we use the graphs to determine the end behaviors, and basically we're going to use our end behaviors along with finding zeros and finding roots and multiplicity to graph polynomial functions, which will be an upcoming video or a next video you can look forward to. So if you have any questions, feel free to send me an email. Hopefully you found everything clear and helpful, and if not, like I said, feel free to send me an email. Thank you so much. Bye.